Okay, I wanted to kind of give an introduction of the yields. You're about to listen to some Khan Academy vodcasts going over it, but I wanted to introduce it myself. We learned in the previous chapter how to go from a gram to a gram, and I told you it was important because we can see how many grams, when we start with a gram of a starting material, how much product do we produce. And so that's why a gram to a gram is important. Okay? Now some vocabulary. First of all, theoretical yield. When we do that gram over m conversion, that is the theoretical yield. This tells us, basically, theoretically, if everything goes perfect, we make no mistakes, everything reacts to the fullest, everything's perfect, and all of your starting material turns into product, what theoretically can we make? And that is that gram to gram conversion. So when you mathematically convert grams of your starting material to grams of product, that is your theoretical yield. Your actual yield is how much you actually get. Okay? So let's say you do the reaction and your theoretical yield is 10 grams, okay? But after you weigh it, you do the reaction, you weigh your actual product, and you only get 5 grams, okay? Well, that tells you you only made 5 grams out of your 10 grams. Which brings me to percent yield, which you do actual over theoretical times 100. So if we did that, we would do 5 grams over 10 grams, multiply that by 100, and we would get 50 grams, or 50%. So that tells us that 50% of our starting material, only 50% of our starting material turned into product. Okay, so basically it tells you how well your reaction went. And the limiting reactant or reagent, this tells us what reactant is entirely used up in the reaction. And it tells us how much product we can make. So let's think about a limiting reagent if we want. Okay, let's say we're going to make Oreos, okay? When we have an Oreo, we have 2 chocolate cookies, right, and a cream filling, all right? So we need 2 chocolate cookies for every cream filling. So let's say we have 6 cookies and 10 cream fillings, okay? And we're trying to produce, what we're trying to make is an Oreo. So we have 6 cookies, I can't write, 6 cookies and 10 fillings, okay? But remember, when we make an Oreo, it takes 2 of these to make our product. Okay, so how many Oreos can we make out of this cookie, out of our cookie number? We can make 3, right? 3 Oreos total from the 6 cookies. But from the fillings, it only takes 1 of these, 1 filling. Unless we're making double stuff. But let's pretend we're making this single stuff. So we can make 10 cookies, or 10 Oreos if we want, with that many fillings. Okay, so which one's going to limit us? We can make 10 Oreos with this one, but only 3 with this one. So the amount of cookies is our limiting reagent. Okay, so the one that limits us, that's our limiting reagent. And then how many Oreos could we make with this material? 3 total, right? It doesn't matter that we have 10 fillings. We could only make 3 Oreos because we only have 6 cookies, okay? So that tells us the max amount of product we can make too. So do you see that the max amount of product we can make is based on the starting material? Okay, so that's what limiting reagent means. So let's actually do a calculation. And this is going to be, one of those gram to grams. Let's see what we have here. Oh, this is more defining. Okay, here's one here. Now this is something we would have in lab, okay? We would mix, salicylic acid with acetic anhydride, mix those together, and we would make aspirin, okay? This is aspirin, like you would take for a headache or something, okay? Now, what we're going to try to find, so this says, what is the percent yield of the reaction? Okay, if 2 grams of salicylic acid, so 2 grams of this, and 1.08 grams of acetic anhydride, right here, are reacted to form aspirin. The final weight of the aspirin actually produced 1.58 grams. So when it says it actually produced, that's what was actually made. So let's write everything we have right now. And this is something we would have in lab. So we would know how much we put in there. Like we have a beaker, and we put 10 grams of this and 1.08 grams of that. And we could say, how much aspirin can we make max? Okay, so that's the theoretical yield. So we have, let's see, 2 grams of salicylic acid, 2 grams, I'm just going to call it SA for salicylic acid, and 1.08 grams of acetic anhydride. And then I think it said the actual yield, I think it said 1.58, but let's look. 1.58 grams. It wants to know what is the theoretical yield. Well, I think it actually says percent yield, but you have to have both to get it. Percent yield, theoretical yield. Okay, so we have the actual yield, and we have the starting material. So this is the, these are the reactants, the starting material. So the theoretical yield, all of this, all the yields are based on your product, how much product you're making. Okay, so we need to see which ones are limiting reagent first. Why? Because that's going to limit, just like with the cookies, how much we make. So there's different ways of doing this. For me, the easiest way to do it is just to go ahead and convert grams of this into grams of aspirin and grams of this into grams of aspirin. So convert both of these, both of them, into grams of aspirin. And I'll show you why that's the easiest thing to do for me. I mean, you could do it a little bit shorter, but might as well go all the way to here. So let's do, here's for our salicylic acid, here's for our acetic anhydride. Let's go ahead and set up our little shell that we have. So we're going to have grams of A. So these are going to be your A's. This is going to be your aspirin. What you're making is always your B. So gram of A, gram of A, mole A, A, to mole A, mole B, and again, mole B, gram B. Okay? The same thing we learned in chapter 3. Not any different. So let me just make a long line. Doop, 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 and do the same thing again. Gram A, because basically we're going to do this twice, because we need to see which one is going to be the limiting one. And basically what you're going to find is whichever one produces the least amount of grams of B, so whichever one has the smallest number at the end of the calculation, that is your limiting reactant. Okay, so let me change my my color. And I already gave you the molecular weight. So remember, up here, this is always your molecular weight of A. This is your ratio. And this is molecular weight of B. Alright, now let's see. This is going to be of salicylic acid. This is a molecular weight of acetic anhydride. And I wrote those down right here. Salicylic acid weighs 138. This one weighs 102. So write those down. So this one, oh right, I already forgot. I think it was 138 and 102. Yes. Okay. Let me write on here. 138 gram per mole. 102 2 gram per mole. And then over here, what is aspirin? 180 gram per mole. I'm getting these numbers right here. Aspirin is 180 gram per, no, go away, mole. Now I'm all over the place now. Okay, so our starting gram here for salicylic acid is 2 grams. Now gram per mole, that's our molecular weight. Our molecular weight for salicylic acid is 138. So 138 gram per 1 mole. Let's do the mole-to-mole ratio. So we're going from salicylic acid to aspirin. So salicylic acid to aspirin. Do you see that there is 1 salicylic acid to 1 aspirin? If there's a number in front of here, so let's say this had a 2, then it would be 2 to 1. But there's not, so it's just 1 to 1. Okay, so our ratio is 1 salicylic acid to 1 aspirin. And then here, again, our molecular weight, but this time of aspirin is 180 gram per 1 mole. Now, before we do that, let's go ahead and fill the numbers in here. This would be 1.08 grams of acetic anhydride. Here's our molecular weight of acetic anhydride, which we said right here was 102. So 102 per 1 mole. Let's look at our mole-to-mole ratio. So we're looking at acetic acid to aspirin. So acetic acid is a 1. Our aspirin, there's 1 of those, so that would be 1 to 1. Just getting it from the formula here. So it'd be 1 to 1. And the molecular weight of aspirin, because that's what we're trying to convert to in both of them, is 180. Because it said we're trying to produce aspirin. That's how I know that. So let me get out my calculator. I'm going to do the first one, the top one first. So 2 times 180 divided by 138. I get 2.6. So let me change my color again to green. This equals to 2.6 grams of aspirin. I'll put a B. And now let's do this one. 1.08 times 180 divided by 102, 1.9. When I multiply this one out, I get 1.9 grams of aspirin. Okay, so I look here. Which one has the least amount? Is 2.6 smaller or 1.9? 1.9. So that tells me my limiting reactant or reagent is acetic anhydride. So acetic anhydride is my limiting reactant, my LR if you want. Okay, why? Because it produced the least amount of aspirin. So we go back to the cookies. Remember, our Oreos, the cookies can only produce 3, while the cream could produce 10, but we're limited by the 3. So this says we can only make 1.9 grams of B. And guess what? Since we went all the way to grams of B, this is also our theoretical yield. And that's why I like to go all the way to grams. It just makes it easier for me. So this is a theoretical yield. So when you go from grams of A to grams of B for both of your reactants, okay, whichever one produces the smallest number, that one is your limiting reactant, and it also gives you your yield, meaning you can only make up to 1.9. So let's see if we can scroll down further. Sort of. I don't think it'll let me write on here though, will it? Nope. Okay. So let's remember, okay, we have 1.9 grams. Okay, so we said we have 1.9 grams of aspirin. This is our theoretical yield, TY, theoretical yield. Our actual yield was 1.58 of aspirin. That's how much, when we did the actual reaction, we weighed it. This is what we actually got, actual yield. So our percent yield is we do the actual yield, so what did we actually get when we did the reaction, divided by our theoretical yield, where theoretical is if everything goes perfect, and multiply this by 100. So if I did 1.58 divided by 1.9, multiplied by 100, I get about approximately 83%. I rounded a little bit there. So that tells us 83% of our limiting reagent, which was acetic anhydride, converted to aspirin, which is our product. Okay, so we were 83% accurate. So what are ways that we can increase our yield? Well, we can maybe do it at a higher temperature. We can make the reaction go longer. We could be more careful when we mix things together. So when you go from one beaker to the next, you're going to lose part of your reagent. So, not using so many beakers, just being careful, don't drop anything. A lot of these things, can make your yield higher. Sometimes adding a catalyst even. Anyway, so I hope this helps. So you have your theoretical yield, which is the max amount that you can make if everything was perfect. Your actual yield is what you actually make when you do the reaction. Your percent yield is when you divide the two, your actual over theoretical, multiplied by 100, it gives you a percent. So it tells you how accurate you were when you did the reaction. And remember, your limiting reagents, those tell you how you're limited, really. When you go from grams of your reactant to grams of your product, whichever reactant produces the least amount of product, that's what you're limited to, because you can only make what you have. So if in our example, we had less acetic anhydride, so that was our limiting reactant and gave us our theoretical yield. Anyway, there's 2 other examples that I'll go into in the next couple of podcasts, and I hope it helps clarify everything.